Okay. Okay. Sorry about that. So, questions from last time? Questions? No? Okay. So let's see. Today we want to talk about annuities, finally. And so in that TVM data table, that will be the PMT. Okay? So we'll start out by thinking about this example. So it says, imagine that one of your cousins gives you her old MacBook because she upgraded to an iPad Pro. She didn't realize, though, that one of your other cousins had already given you her old Surface Pro 3 and that you've actually gotten used to it. So you list the MacBook on Craigslist for $500. Okay, so you list it for $500. A friend of a friend is starting a business and heard about your listing. He needs a MacBook for his business, but he's short on cash now. So he pleads with you to let him have the MacBook now and promises to pay you $280 for 2 years. First, $280 in 1 year, and then the final $280 at the end of the second year. Your other friend, who is an underwriter in the commercial loan department of a local bank, tells you that the rate for short-term commercial loans is now 8%. So should you accept this offer? Actually, you know what? I might have loaded the wrong. Did I load? Okay. Yeah. Is this what you have? Is this what you have, actually? Let me see. No. Oh, sorry. Open. Okay. Yeah, okay. Oh, come on. Oh. Let's see. Yeah. So this is the one, right? Yeah. Okay. Open file. Hello. Yes. Sorry about that. What would you do? How do you start to think about this problem? Any takers? Let's just start this over again. Yeah, okay. So how would you start this problem? Does it remind you of anything that we looked at? Does it remind you of anything we've seen before? What? Finding the present value, right? So what's different? What should this remind you of? Sometimes, right, when you're trying to get your head around things, you can try to draw a cash flow diagram. Right? So one cash flow diagram would be the $500 at t equals 0. So that's kind of what you had in mind. You thought that you would, trade off the laptop and get $500 possibly, today. But someone else has offered you $280 at one point in the future, and then a second $280 at a second time in the future. Right? So last time it was, $100 today, and maybe $102, $105, $110. 1 year from now it's $500 today versus a split of $280 in the future. So it's kind of related to the problem that we've seen before, but a little bit different. So what should you do? You have, so what do you think? So there's a cash flow at t equals 0, and there's a cash flow at time equal 1, and a cash flow at time equal 2. So what should you do? Very good, right? Because in all of the, so first of all, you kind of read this and you think, okay, this is not a CVP. This is not a cost volume profit, or it's not variable cost, fixed cost, it's not that, right? So it's got the only other framework we have is TVM, and you must have an interest rate. So somewhere in there, there's an interest rate. Where's the interest rate? Right? Someone, one of your friends, so you found out that a commercial loan department, so for commercial loans, right, to businesses, and so is this kind of a business situation? Well, the friend has a business, right, and wants to buy the MacBook for his business, right? So maybe a commercial loan rate would be appropriate. Does that make sense? Of course, there's only one interest rate in this problem, right? So the interest rate is 8%. Okay, and it doesn't say anything about compounding. It doesn't say compounded quarterly or monthly or something. So what do you assume if it doesn't say anything? Annual. Okay, so you always assume, I'll just say assume annual. Okay, and so, I mean, even if it did say 8% compounded, quarterly, the 8% would be the annual amount, right? And then it would be compounded quarterly or compounded semi-annually or whatever, right? So the interest rate that's stated is always over a full year if you deposited for the whole year and then compounding would afterwards. Again, here so there's no compounding, so assume it's annual compounding. Okay? So last time or before, there was a one cash flow at 1 year out. So we know how to do that, right? So we could actually draw sort of peel off this one and say, well, we know how to do this, right? Because we did it before 1 year, right? This was like 110, 105, 102, right? And the other one was 5%. Now it's 8%, right? So we know how to get this present value. But then we would have this other one left over, right? So could you do that? What is this? This says basically what's the present value for a single cash flow 2 years out, $280. Could you do that? Should be saying yes, right? Right? So definitely, we did this last time, right? And then 2 years out, you should be able to do that also, right? So that's basically what we did, what we do, right? If you have a series of cash flows, you basically do them one by one, right? Because this is a cash flow, and so it has a present. So here's the actual total cash flow, but we can break it into this one, and so there's the contribution from that cash flow, and then here's the other cash flow. There's a contribution from that cash flow, and then if there were other cash flows, there would be contributions from each of those, right? So we find all of their present values, and then we add them all up, and then that's the total present value for all the cash flows. Does that make sense? Right? That's basically what we do. Okay. So algebraically, this is what it would be. The present value is the future value for the first one. So this would be kind of like an FV1, and this would be like an FV2. 2, right? Or actually, maybe I should say that this would be FV1 equal, and then FV2 equal, right? Or sorry, I should actually have this 1 plus I, and then 1 plus I squared. 1 plus I squared over there. So the present value is this future value divided by this factor, or multiplied by the discount factor, or 1 over the whatever it is, right? So this is what it is. And so here, this FV is 280. This other FV is the same, 280. And then the interest rate is 8%. So we do the factor as 1.08. And then so that would be this one time period out. And then this squared would be for the one that's 2 time periods out. Yeah? So then if you square that out, you get this. And then if you actually punch that up, you would come up with $499.31. So what would your decision be? Don't do it. Don't take the 280. Why? Because what? Because you're asking for 500, and the present value is a little bit less. So you could say that, or you could say, you know what? It's close enough, so I'm indifferent. Whether I do one or the other, I don't care. But you're right. You do want to see that if the present value is lower than if the present value of these cash flows is less than the money in the bank, you might take this one. The other thing you could say is, you know what? Since they're actually so close, there's a risk, right? What is the risk? The risk is that he might make one payment, and then 2 years out, I don't know, right? So the present values are kind of coming out to be very similar, and so you'd say, well, this one is guaranteed, right? Because if I sell it for a lump sum, I have the cash as soon as the buyer buys it from me, right? Whereas if I have these IOUs, these promises to pay, I don't know. Okay, but actually the 8% sort of kind of is a way of factoring that in, right? Because you have to imagine the bank, right, makes lots of loans, right? So most of them will actually be okay and go to maturity, but a few of them will actually be in default, somewhere along the way. And so this 8% kind of should bear that fact in mind, so that if you make 1,000 of these loans or 5,000 of these loans, yes, a few of them will go bad, but then enough of them will actually be fulfilled that you actually overall will still make a profit. So that's part of the sort of risk premium that would be factored into an interest rate. Okay. So if you wanted to do this in Excel, you could do the present value formula for one piece, and the present value for the second one, and then it turns out that you'd actually come out with the same thing. And then of course, if we have the calculator, right, one thing we could do is we could clear the TVM registers, clear TVM, right, and then we would put in say 1 for n for the first one. We put in 8%, right? We want to compute the present value. The future value would be 280. And then I think I want my number to be positive. So even though it doesn't, I would be receiving this, I want my present value to be positive, so and I know that it's going to flip the sign around. So I'll just pop that in for the future value. So then I compute the present value. Okay. So actually, I think if I go equal, I can go back and have this number. And one thing I can do is the calculator actually has 10 different storage cells. So they're numbered 0 through 9. So what I can do now is I can store this in 0. Okay? So that would actually be the computation of this first present value. Okay, and then remember that it's sometimes called discounted. So if the actual cash flow is 280, the present value will be less than that. Okay, so now I want to calculate this other half of it. Sorry, and so all I have to do is basically go to the second exponent, right? And now the interest rate is the same, the future value is the same value, right? And so when I do compute PV, I get this other value. So again, it's a little bit less because why? Because it's a little bit further out, and so I'm dividing. So before I divided by 1.08, and then when you square 1.08, you get something larger. So you divide by something larger, and so the result is actually smaller. Okay, so I can do equal again. And now what I do is if I just do stow 0, I'm going to push this value on top of the one that's already there. So I can actually go stow and then plus and 0. And so what that does is it takes this value and it adds it in to what was there. And so when I do recall 0, actually I bring back the value that was stored there. Okay, so you don't have to keep copying things down and then punching them back in. Okay, and so there are actually 10 of these. So I could have stored it in 1, and then I would do store plus 1. If I stored it in 5, then I do store plus 5. So the the trick is to remember them. If you do get confused, there is this mem over there, right above 0. So you can do second mem, and then this shows you the value that's in memory cell 0. That shows you what's left over in memory 1, memory 2, memory 3, memory 4, memory 5, memory 6, memory 7, memory 8, memory 9, and then it goes back to 0. And then, of course, the arrows go up and down, so you can see what's there in the memory. So I'm going to do to go back to the regular mode. I'm just going to sort of quit out of that, kind of looking at the memory worksheet. You can think of it as a worksheet. Okay, that makes sense. Okay, and so you could say you're indifferent, but anyway, okay. The other way to do it would be to use these tables, right? And so basically you would know that in order to look values up, these factors up on the table, you need the n, the number of periods, and the interest rate. Okay, and so here the interest rate is 8. For the number for one of them will be 1, and then there's no annuity at the moment, right? And so you could look at the present value factor for 1 and 8% times 280. So that would be for this first one over here. So this is another sort of getting ready to use a table way of this. And then the second factor would be the end is 2, right? And then what you do is you look them up, right? So it will be 1 and 8%. So the first one is over there. Okay. And then the second one would be, 2 and 8%. So it would be 2 and the same 8%. So that will be this number. Okay. Right. So this value is actually 1 over 1.08, and this value is actually 1 over 1.08 squared, or 1 over 1.1664, and maybe a little bit more. Okay, and then this value goes over here, right? So you can add those up, okay, and then multiply by 180, and you still get the same amount. And then, if the values differ by, the fifth place, right? The pennies in this case, it's actually okay because of a little bit of rounding here and there. That's good enough. Okay. Does that make sense? Right. So if there's anyone who's super, super sharp, you might look at this number, and you might notice that this number is actually somewhere else on this page. Sorry? Like right over here? That's it. So this number is actually on the ordinary annuity table. So what does that mean? That means that another way to think of this problem is to think of it as an annuity. Okay, so actually, do you see any other numbers that are repeated? If you look very carefully, zero, 9, 2, 5, and you see that over here. Yeah. And then maybe this one you see over here, right? And then maybe this one you see over here, right? Other than these, you know, this sort of doesn't count, that those are repeated. Yeah, so what's going on? So what's an annuity? Why is it that for the PV table at 1, the value is the same as the ordinary annuity? And then, so how did we get this number? We added this and this, right? So we copied this one over there, we copied this one over there, we added them, we got this. So actually, the way to get this number is to take this one plus this one, and you get that one. So how do you think you get this one? You take this one and this one, you add those two up, and you get that one. Right. And you take this one, and you add this one, and you get that one. Okay, what if you took this one, and you added it to this one, and you added it to that one? Where do you think the sum will be? What's the sum of this one, and this one? If you add those three up, you get 2.77509. Is that right? So if you take this one, plus this one, plus this one, you get this one. If you take this one, plus the third one, you get that one. You take this one, plus this one, plus this one, you get that one. Okay? So the annuity, ordinary annuity, annuities are related to present values. Okay? So when we first looked at this problem, we looked at this as an individual cash flow, and then we also, right here, so we took that present value, and then we took that present value separately, right? So the other way to look at this problem is to spot it as an annuity. Okay? So what is an annuity? Okay? An annuity is where you have, so annuity. Does anyone know what an annuity is? You know? You've heard of the term before? You've heard of it, maybe some of you have heard of it. Do you know what it is? It's actually I guess sometimes people call it a level, or same amount. received or paid at constant intervals of time. Okay, it's a level or even or same amount. I kind of at constant intervals of time. So here's an interval of time which is 1 year, and then there's this value, and then after the same amount of time forward, there's this level, even or same amount received, and then it actually it's done. Okay. But you can imagine that the stream, sometimes people call the annuity a stream of cash flows, the even stream. Sometimes the stream could be 3, 4, 5, could be 10 years, 20, 30 years, right? Then you can look at it as an annuity. Okay? So how do you look at it as an annuity, right? Basically, in the financial calculator, right, let's just sort of clear everything off, right? We say that there's actually 2 of them. We say that there's the same interest rate. And now we put this 280. Instead of putting it in the future value, which is only one single, the future value always represents the one single cash flow at the end, we put it into the PMT. Okay? Then when we compute the present value, we get the present value for that stream of cash flows. Does that make sense? Okay. So what's actually going on? See, so we'll sort of ignore this. What's actually going on is at this step, or this step, either of these steps. See, before what we did was we did this division. We got a number. We saved it. We did this division. This exponentiation division. We saved it and we added them together, and then we got the number. The other way to do that, right, is to say, well, I have this 280 in both of these terms, so what should I do? I have a 280 in this term plus, and something else, plus 280 and something else in this term. What should I do? There's a plus sign there. Or I could factor them out, right? No? Because what we did before is so we don't want to repeat what we did before, add them together, right? So here's a 280 in this piece. Here's a 280 in this piece, right? So we can factor it out. So what would that leave? That would leave 1 over 1.08 plus 1 over 1.1664 times 280. So this, right, is this 0.92593 plus 0.85734. And so that's the 1.78327. And then we do the multiplication of 280 at the end. Does that make sense? So if we do it the sort of basic approach, we're doing this whole numerator divided by denominator as one problem for one present value. Then we're doing this next one as this numerator divided by this denominator as one separate present value, and then we're adding them together, right? But this is math, right? And so in math, if you see a factor, right? If you see a factor in math, you're allowed to pull it out. You're allowed to factor it out, right? So then basically we do the addition first, right? And we get this number. And then we do one multiplication at the end. Does that make sense? And so that's why the ordinary annuity table is basically the sum, or adding up these present values. You can think of the ordinary annuity table as the running sum, right? So running sum means, so if there's, that's why for the first row they're exactly the same, because an annuity, a level payment, constant level payments, if there's only one interval of time, it looks just like the present value. Does that make sense? So this is kind of like the degenerate case where there's an intersection. They're absolutely 100% equal. Okay. For the next one out, this one is the one single cash flow 2 time periods out. Okay, so all of these are one present value of 1. That's like the future value, like 1 cash flow at 2. So there's like pukas, right? So here at 3, there will be no cash flow at time 1, no cash flow at time 2, and then the 1 cash flow at time 3, and then we're at 4%. Here there's 1 cash flow at time 3 at 6%. Same thing here. What the ordinary annuity is, there's a cash flow at time 1. Like if we think about this one, there's a cash flow at time 1, there's a cash flow at time 2, there's a cash flow at time 3. All 3 of those are the same, so let's do the addition first. Let's add all of these 3 up, that's that number. And then you multiply by the cash flow at the end. Does that make sense? Yeah? Okay. So that's actually basically what an annuity is. Okay, so now I just want to mention that there actually are 2 variants. There's 2 types of annuities. One type of annuity is called an ordinary annuity, and that's basically what we'll be doing in our class. Okay, and so this is the annuity where there's no payment at the beginning, and then all of the payments are sort of at the end of the period. Okay, and so you'll notice, by the way, if you go into Excel, we've talked about for the the PV function and the FV function that there's a rate first, then the number of periods, and then we've been saying annuity, let's just set that to 0, and then occasionally we've actually set the future value, right, in the beginning, and then the last sort of bracketed variable is this type, and so the value is either 0 for the end of the period, and that's default, so the annuity would be at the end of the period, or the other choice would be 1, and that means that the PMT is actually at the beginning of the period. Okay, so financial borrowings such as loans, mortgages, and bonds, and maybe some rentals where you pay at the end, those you model with, or those are where you would use an ordinary annuity. But not all business contracts are like that. Not all business dealings are like that. Basically, an insurance policy, right? You pay your premium up front, and then you receive coverage afterwards. You pay your premium. So basically, that would be your premium at the beginning, and then you have coverage. You pay your premium at the beginning, and then you have coverage, right? You pay your premium at the beginning. Your last one. You make your last payment. Then you have coverage, and then that's it. No more coverage after that. Okay. So also leases, like rental agreements, you pay up front, and then you enjoy the use of the property. So you pay your rent, and then you stay in the property. You pay your rent, you stay in the property. You pay your rent, you pay your last rent, you stay in the property, and then it's over, so you have to leave. Okay. So rental agreements are also like annuity due. Okay. So that's why there are these 2 different ones. Okay. And so for our class, we'll just keep it simple and deal with ordinary annuities. But I do want you to know that there is such a thing as annuity due, so that if you encounter that in a class, your mind doesn't say, "Oh, I don't know what an annuity due is." Okay, you actually do know what an annuity due is, and we'll sort of punch through some examples. And if you have to in Excel compute the annuity due, then you just set this last value to 1. Okay, so if you're dealing with an insurance policy or dealing with some kind of a lease or rental, and you use the PV function, it's this similar idea, right? Except that you now must enter the value 1 at the very end. Okay, and similarly on the calculator by default, on the TI calculator, default is the ordinary annuity. And so the question is, okay, well, if you have the annuity due, how do you do that? So basically, there's this flag, and it's called kind of BGN, which is beginning, right? So payment is at the beginning of the period. And so you kind of go there, and then you either set it, and then the flag is there, and then when you want to switch back, you just go back there and you set it again. So it's what's called a toggle, right? So you basically toggle it on and off. So let's kind of go back to our normal mode. And then if you look at, and it, where would you expect the BGN flag to be? Right above the annuity, right? Because it relates, why? Because it relates to, is the annuity payment at the end of the period, or is the annuity payment at the beginning of the period, right? So why not put it right above the annuity, right? So if you go to second BGN, you can see that it's at the end. And so the right above enter, there's set. So we do second set. And now you can see it's BGN. And so when we go second quit and go back, you can see that the calculator tells you that now all annuities are going to be annuity due, where they'll be considered that the annuity payment is at the beginning of the period, BGN. So it's like you kind of can't miss that, right? So it kind of lets you know. And then now, of course, if you want to go back, you just go to that same toggle switch and do set and toggle it back. So we just go right to second BGN, and so we do second set. And you notice that it says end, and the BGN went away. So let's do it again. So we do set, we set it, and so now it says is the beginning, and so that flag is there. And then we do, just do it again, right? You can see that it just toggles it. So just on or off, beginning or end, right, sir? Okay. So now we're back in the ordinary annuity, which is again the more common case. Okay. So just sort of file that away. And so here's just a note of that in Excel, right? Sometimes, people will explicitly put a 0 there because they want to be clear that they're doing ordinary annuity. And obviously that's not wrong. You just have to, put that in. If you leave it out, the default is 0, ordinary annuity in Excel. Okay. So now let's try a slight variation, right? So imagine that one of your cousins gives you her old MacBook, right? So because she upgraded, right? She didn't realize another cousin giving you the old Surface, right? You actually gotten used to it, right? So $500, right? Same thing. He needs his MacBook, short on cash. He pleads with you and promises to make 4 total payments of $130 every 6 months. So let's just make a note of that. So 4 payments, 130 each. So basically every 6 months, so that would be semi-annual. So let's see, 4 times 130, right? We could think of that as 4 times 13 times 10, right? So 4 times 13, that would be like how many cards are there in a deck, right? 4 times 13. So 52, right? 52 cards in the deck times 10. So 4 times 130 is equal to 520. So $520 is more than 500, so we should take it, right? Right? I don't know about this, right? So what could throw things off? Time value of money problems always involve interest rate. Okay, so if you just do this calculation, where is the interest rate is equal to, you neglected the interest rate. Okay, this is a time value of money problem, right? And so in a time value of money problem, you don't do this, right? No. or maybe it might come up, but you don't base your decision on this type of analysis, right? You must take into account the interest rate. Okay. So here, the interest rate is a little bit different, right? So 8% compounded semi-annually. Okay, so that's our interest rate. Okay, so sometimes in the beginning, it's useful to draw out the cash flow diagram, right? So we have t equal to 0, and we have 4 time periods, right? 1, 2, 3, 4, and then if you leave out a value, it's implied 0, 130, 130, 130, 130. Okay, and then you might make a note that actually this is 1 year and this is 1 year. Okay, 1 year, 1 year. So it's semi-annual. So what is this? There's 1, 1, 1, 1. It's an ordinary annuity, right? It's a level or same amount received or paid at constant intervals of time, right? So, do you want to do this present value once, and then this present value 2 years out twice, then a third present value 3 times, 4, like that will get kind of repetitive, right? So you don't want to do it the FV, the future. You absolutely could. You would get the right answer, except you would have to compute this present value for that one at one time period out. You compute a second present value, a third one, a fourth one, then you add all those up at the end. Why not look at the annuity, basically add them all up at the beginning, and just do the one multiplication at the end? Okay? So how should we get started? After you draw the kind of visualize maybe what's going on with the cash flow diagram, to actually get the calculation right, I think it's a good idea to fill in that TVM data frame. Okay. So it starts out with what? Compounding, right? And then, if you think along, I sort of think of it along the lines of the calculator. Right? After you get the compounding, it's N, I, PV, PMT, FV. So it's kind of, you just have to remember, so obviously there's 5 over here, but you have to remember the compounding is off at the beginning, so that would be C. So then there's the cash flow. So these 3 sort of deal with the environment. Okay, then there's the PV, the annuity amount, PMT, and then the FV, right? And so these are the cash flows. Okay, and then you always start out with 1. Okay, so and this actually means annual. Okay, and so here, kind of jumping ahead, or if you know that this is semi-annual. So when we see that this is semi-annual, where do we put this information on the TVM data table, data frame? Sorry? Under C. We build up the second row, right? So this is the semi-annual. I'll just put semi. Okay, because 2 payments per year. Okay, so the compounding is semi-annual. So as soon as you see the compounding semi-annual, you'll know that you need to build up the second row. Okay, so at the annual level, how many annual periods are there? 2, right? 2 annual periods. And I is the interest rate, right? So we know that's 8%. The PV, what's the PV? Present value. Is the present value 130? The present value is, that's what you want to find out, right? So these problems, like sometimes you want to find the future value, sometimes you want to find the present value, sometimes you want to find the annuity amount actually. Sometimes they're kind of bizarre and they want you to get the interest rate, you know, and these constraints, how much the interest rate do you need? Sometimes, you know, you want this as my beginning cash flow, I want these and that. How many years is it going to take me to get to that objective? You know, so sometimes you can solve for n. So, it's actually, you know, just math, right? And so as long as you have the 5 others, some of these really mean questions ask you to find the compounding actually. Anytime you know 5 of them, you can actually get the other 1, okay, of the 6. Okay, but so that's why I think it's helpful to throw in the question mark. This is what I'm looking for, okay? PMT, this is the annuity amount is the amount that's level and that's repeated. Okay, so that's 130. And then in this case, the FV is always the single one cash flow at the end, stray cash flow at the end. So in this case, there's no FV. So one way that FV is always the cash flow at the very, very end. Okay. Actually, right now, it's you know, so you could say, well, why isn't this the FV? And the answer is, we could make it the FV. It's your choice. So one method, one approach to one framework to think about this problem is to say we have an annuity of 3. Okay, and then our 4th one is, you know, 130, but that's our FV. But actually, no, I take that back. No, it won't work. You would have to do an annuity of 3. And then you'd have to do an FV of 4. Okay, so if you do the annuity, it runs until n. Okay, so you should really think of this picture where the n time periods, your annuity for an ordinary annuity, there's no cash flow at the beginning, and it runs all the way until the end. Okay, so if you wanted to think of this problem with an FV, you would think of an annuity of 3, and then you'd have a single FV at 4. Okay, but then you'd have to do like part annuity and then just 1 PV for the future value. It really makes much more sense to just lump all of these together. Okay, and so in a little while, we'll actually do what's called a bond problem, a sort of the vanilla plain corporate bond, and then that's where FV will come into play. So for now, at this stage, we'll either be doing FV problems, in which case there's all these pukas over here, and there's just the 1 at the end. Okay, and so that's what we did at the very, very, very beginning today, where we had, this is really an annuity, right? But we didn't know it was an annuity yet, and so we had this as a single FV, and there's a puka, and then we had this FV at the end. Okay, so we did this as 2 FV problems. Okay, so usually, obviously, there's only one here, so there's no puka, there's no gap. So usually FV has a bunch of pukas, except when it's FV1. Okay, usually FV has all these pukas in there, and then or empty spaces, holes, and then the PV fills them all up. Okay, so here, so that's why it can help to draw the cash flow diagram, because then it helps you to visualize what's going on and kind of fill in the table, right? Okay, so it's all filled up and they're all level, even. Okay, so it's a PMT, and then there's no additional amount over and above the annuity amount, and so that's why the FV is 0. There's no additional amount because the annuity PMT runs all the way to the end for ordinary annuity. Okay, so how many compounding periods are we dealing with? 4, right? And so we get that by taking the annual number of periods, 2 years, and we multiply by the compounding, because there's 2 compounding periods in each year. So the total that we're dealing with is 4. Okay. Now again, this 8% interest rate is over the entire year, and so since this is semi-annual compounding, we're only going half of that amount, and then we're doing interest, and then the second year is the second half of that amount, right? So we actually take this and we divide by this C. Okay, and so we get 4%. Okay. So actually, technically speaking, the 130 should be down here, and this could, technically speaking, this should actually be 260, because we're dealing at the annual level, and over the total year you'd be collecting 2 of them. But actually, we don't really use this first row is mostly to help us get the second row, and so whether we actually had the mistake of 130 there or the full 260, again it's based on this compounding over here, right? So we would use this one down at the end. Okay, so I think just for sort of jollies, if you really wanted to do it the long way, you would come out with this, and so you might get a tiny bit of rounding, but we don't want to do not want to do it this way. This is sort of a way just to check, right? And so we'll go to the calculator, right? So again, clear TVM, so right, so clear all of the TVM registers, right? And so what we want to do is we want to put 4 in for N. So you do 4 N. We want to do this 4% for the interest rate. So we do 4 in for the interest rate. And PV is what we're trying to figure out. Might copy that down. So it's kind of optional whether you want to copy that down or not. So don't touch that. And then the PMT is 130. And I think I want my answer to be positive, so I'll just do that. And then we can, obviously we cleared everything, so we know that the future value is 0, but you can always just check it if you want. And so when we compute that, compute the present value, we get the annuity amount. Okay, so once you kind of get the hang of it, you can actually become more efficient and get them very quickly. Just for the sake of demonstration, right? We'll go to BGN, right? And we'll set it. Set, okay? And we'll go back. And now, if we say compute the PMT, oh sorry, wrong one. 130 back PMT. If we compute the present value, we're getting 490 instead of the 471, right? Because the cash flows, right now as BGN, we have this 130 over here, right? And then these guys are shifted a little bit. So this one basically is shifted over there instead. Okay, so if you wanted to say do this in Excel, no, right? Right. Very quickly, it's not so difficult. Oops, it's too slow. You might do C, right? N, I, PV, PMT, oops, PMT, and then FV. Okay, and then I'll just do the second row, right? 2 for 4%. PV is what we want to figure out. PMT is, we'll just do minus 130, and then FV is 0, right? And so the PV is equal PV, and then it's this 4%, comma, okay, N is there, and then comma, PMT is there, and then we can actually close it off with that. Or if, if we wanted to do, so this is ordinary, and then if we wanted to do, we would just do, let me see, actually, oh yeah, no, equal PV, right? And then we would do the rate of 4%, same as before. The number of periods, same as before. We do the PMT, same as before. Here, we need to get out to the last value, so we have to explicitly put in 0 there. Now, oops, now we're at this last type, and you can see 0 is a default. If we do 1, we get the annuity due value. Okay, so that's just for demonstration purposes, right? So it's about the same, right? And so, what if you need to do the annuity due? It's just that last, that very last, very last value is 1 instead of the default 0, and then it's this BGN up there, right? So now let's just go back to BGN, and then we'll just toggle it back to end and go back to where we'll pretty much stay for the rest of our course. Yeah. Okay. So that's annuity. So, you know, if you don't accept the offer, oh yeah, so what should you do actually, right? What's your decision, right? The offer of 130, even though it sums up, if you just do the straight multiplication, it's 420, that's more than 500, right? If you factor in the 8% semi-annual interest rate, then it actually, the present value comes out to be below 500. So what should you decide? Right, no, because PV of, you know, we'll just call it 472, right, is less than 500. Okay, so you might say, well, you know, I feel bad. Say, well, if you really want it, you could go to the bank, right, and get a loan, right? And then if you borrow 500 from the bank, then you have to have 500. You could give me the 500, and then you have to make payments to the bank. But then the question is, what would be the semi-annual payment to the bank? Okay, but well, actually, it turns out that it's actually related to a mortgage, which is what we want to think about next. And so, what is a mortgage? It's often used, right, in real estate, right? So purchase like a home, apartment, or other kind of property. If you look at this root word, mort, right? a mort sort of has to do with like morbid topics or like mortuaries kind of thing, kind of has to do with death. So mortgage, you can think of it as a plan to kill off a debt. Okay, killing off a debt is a good thing, right? It's not such a good, not pleasant topic to talk about in general, but getting rid of a debt, that's a good thing, right? So it really is a plan to kill off a debt. Okay, so let's say an individual takes out a 30-year residential mortgage for $100,000 at 6% interest. What is the monthly payment? What is the monthly payment? So, as always, you know, we should think about the cash flow diagram. So t equals 0, 1, 2, and then it's 30 years, and even though it doesn't say, you know, compounded monthly, it's a mortgage, and it's asking for the monthly payment, and mortgages are always compounded monthly anyway. And so kind of as residential mortgages, I mean, they're always monthly. So it doesn't really have to say compounded monthly, right? Because it's a residential mortgage, and so everybody knows that it's compounded monthly. So if they're 30 years, how many compounding periods? If there's 12 months in 1 year, that's a big number. 360, right? So the second to the last one, the penultimate one will be 359, and then the ultimate one will be, 360. Okay? And so every month, what does the person pay? So they're going to receive this. Oh, so when you borrow at the mortgage, you get 100,000. So what's that? In our cash flow, where do you get the 100,000? Where do you put the 100,000? Future value? But when do you need the cash? You need the cash at the beginning, right? Because you're going to get the cash from the bank, and then you're going to give the cash to the seller. So you're borrowing 100. It's like it feels like you never see it, right? But you actually get the 100,000 from the bank, then you give that 100,000 to the seller. Then you get the property. You get the keys to the property, right? And then you have this loan that you have to keep paying back to the bank. So where is the 100,000? The 100,000 is at the very beginning, right? To start it out. It is weird because you don't see it, right? It's a lot of cash, and you don't see it, but it goes to the seller. So now then you have this monthly payment. So what's your monthly payment? Monthly payment is a same amount, and it's paid at regular intervals every month to the bank. So that's the level payment that you always pay every month at a regular interval of time. That's an annuity, right? This is an annuity. So how much do you pay? That's the unknown, right? That's what we got to figure out. Is that right? It's math. So we make it, we don't know what it is, so we make it a variable. We call it a PMT. That's our unknown. Okay? So C, N, I, PV, PMT, and FV. And we always start out with 1, and we're going for 30 years, and this is at 6%. Our PV is 100,000, and our PMT is our unknown, and this is monthly compounding. So this is 360. This is actually 0.5%, right? 6 over 12 is 0.5%. And we want to figure out what's our PMT. Can we solve this problem? We can solve it. Why? Because a mortgage is a plan to kill off a debt. So how much is due at the end? 0. Right? Because it's a mortgage. And the obligation, the debt has been killed off by the end. Does that make sense? So, we can go for it. Right? We do, oh, sorry. Yeah, that's it, right? So we do second, clear TVM. We have 360 monthly compounding periods, right? 360. So that goes into our N. Our interest rate is 0.5, monthly interest rate is 0.5. And the PV is 100,000. And so when we compute the annuity amount, it's $599.55. 599.55. Does that make sense? Yes?
So when you're doing your calculations, you don't put anything into P/Y when it's per year, or when you...
That should be 1.
Okay.
If you look back a few notes ago, my recommendation is that in this PY, CY, you should always make those 1. Okay. And if, on the other hand, you become a real estate professional and you're always dealing with monthly, then it makes sense to put 12 in here. Because the moment you put 12 in there, all of these registers are perfectly set up for monthly compounding. Then the next problem that you get is going to be quarterly compounding. And so then you'll have to go in and switch this to 4 to make everything quarterly compounding. And then you get a semi-annual. So while you're a student, my recommendation is to set this to be 1 while you're a student and handle the compounding in the table. Okay, because if you handle this compounding stuff in the table, these are the same values that you'll be using in Excel. And also, if you're stuck in accounting classes, you will have to use these table. Or did I say table? I'm in Excel. So, but these values are the same for as long as these values are 1, these are the same in the calculator, the tables, and Excel. Yes? Where did I get 12 and 0.5 from? Good question. Very important question. So this box is always the product of N times C. So this is N and this is C. So N is 30 years and C is 12 months per year. So that's 360. 3 times 12 is 36 times 10. Okay, and then this one is always I divided by C. So you take this one, and then whatever this is you divide it. So it's actually 6% divided by 12, and so that's basically 0.5%, and then in decimal it's 0.5. Got it? So that's why you set this up. Just read this pretty much from the problem. Put this out here. As soon as you figure out the compounding, set it out here for your second row, and then concentrate on getting everything right. And then you just multiply these two, and then that one you just divide. Okay, and so this is how you handle the compounding. If you do it this way, these are the same values that you put into Excel. So let's go to a new sheet. Maybe I'll just keep this one. So here, we'll just do the second row, right? 12. N is 360. Oops, 360. Rats. Actually, no, I should really do it the right way, right? N would be 30 years, right? This would be 6%. Oops, 6%. Our PV is 100,000. In this case, question mark is at the there, right? So let me just okay. So now we do 12. So actually, what you should do is you should not type in 360. You should do that one times that one. Okay, and then for the interest rate, you should do this one divided by the head of that row. Okay, oh, and then if you want, you can actually switch that to be percentage, and then I'll just show two places, fine. Okay, 0.5%. Okay, and then you do equal PMT, and you refer to this rate, which is 0.5%. You refer to the present value. I kind of want the number to be positive, so I'll make that negative. And then, oh, whoops, wrong one. Let me just back up over here. Oh, whoops. It's easier to just do it this way. So the number here is 360, right? Now we have the present value. So I want that. I want my result to be positive. So I'll put in a minus sign there, so that is negative. So there's my 599.55. Okay. So what we want to do, of course we're out of time, is what we want to do is we want to sort of prove why that's the case. And so we'll do the amortization table next time. So rats. So I have to adjust the homework because there's an amortization problem on the homework. So let me adjust the homework. So don't do it yet. But the next thing we want to look at is we want to look at the amortization table, because the question is, so you get this number, 599. How do you know? How can you prove beyond the shadow of a doubt that it really does kill off the debt? Okay. So the way, yeah. So I can give you these amortization problems, the PMT problems. I can't give you an amortization table. Okay. So the next major topic that we'll accomplish on Monday is to actually kind of go through this, to build the amortization table. Okay, and then you can see that the principal balance is really being killed off and is going to zero. And the way that happens is actually through this. And so we'll explain this about the amortization, about the monthly payment next time. Okay, so have a good weekend. Oh, sorry. Yeah, and the quiz is E102. E102. So if you go to the NetLab where you can get accounts and print, that's E101, and so it's right across the hall. So it's almost straight out the door.
Okay. And for our quiz, we have a little bit of everything that we've gone over.
Yes, this week.
Yep. Study everything.
The homework. Look at the homework problems. Yeah, so you can revisit them, and they should change. The algorithmic. Study attempts. Yes.
Okay, cool. Thank you.
Okay.